Today's lesson is about inscribed angles. Now, to understand what an inscribed angle is, you're actually going to start on your Chapter 12 postulate paper. So turn to the postulate paper and find the inscribed angle theorem. An inscribed angle is like this one in blue. It's an angle that is contained by a circle where the vertex of the angle is on the edge of the circle and the rest of the angle cuts through the circle to some extent. So it's not a central angle that starts at the middle, it's one that starts on the edge of the circle. That's an inscribed angle. The inscribed angle theorem says that the measure of an inscribed angle is always half the measure of the arc it intercepts, or the arc it cuts off from the rest of the circle. So look at this example. See how this inscribed angle cuts off this arc of the circle? That's the intercepted arc, the part that's cut off from the rest of the circle by the ends of the angle. The rule is the inscribed angle here is always half the number of degrees measure of the arc it cuts off. Half of 64 is 32 degrees. Now, a quick reminder, the measure of an arc is really telling you the measure of the central angle. Here it's saying that this arc is making 64 degrees above if you connected it to the center of the circle. And you could kind of picture that angle and see how it would be about twice as wide as the 32-degree inscribed angle here. So really quick example that's not on your worksheet. If you wanted to know what the inscribed angle ABC was, you would just take the intercepted arc and half it, 25 degrees. Now your turn. I want you to try to figure out question 1, A, B, and C as much as you can. Pause until you're done. So for number 1, if the central angle is 60 degrees, the arc between A and B is also 60 degrees. The inscribed angle here would be half of that, so x equals 30 degrees. Part B, here the intercepted arc is 102 degrees, so when you halve that, the inscribed angle is 51 degrees. For part C, you're working backwards because this time you know the inscribed angle is 24 degrees. Working backwards, knowing that that is half of the arc it cuts off, you could figure out that the arc here is twice 24, 48 degrees. Pause here and see if you could figure out question 2 on your own. So for question 2, you first want to figure out the missing arc here. If you add the other two pieces of the circle and know that the whole circle has to add up to 360 degrees, you could get that the missing arc here is 174 degrees. Once you know this arc, you could half it to get the inscribed angle A. Now, a tip I have for you when you have multiple inscribed angles that are all overlapping in the picture, gets kind of confusing, is to pick one inscribed angle and highlight it and see what arc it ends up on. For example, if you look at the inscribed angle 45, it ends cutting off arc B. In other words, it's half of arc B, so you could double the 45 and say B is really 90. The same process can work to help you solve for x in the same diagram. See where x is? Highlight the angle x is in and figure out what arc it's cutting off from the rest of the circle. Oh, x is containing the 76-degree arc, so you could half that and say x equals 38 degrees. Pause here and see if you can figure out number 3. So I want you to notice that this chord here is actually a diameter because it's cutting through the very center of the circle. That's going to be important. It's cutting through the center of the circle, so you can assume that this arc is exactly half a circle, 180 degrees. If you highlight angle 1, the arc it's cutting off is 180 degrees, so you half that. Angle 1 is 90 degrees. For part B, first highlight angle 43 you could figure out that the measure of the arc it's cutting off is twice that, 86 degrees. Notice, however, that the angle you're solving for actually ends on the same arc. So angle 2 has to be cutting 86 degrees in half. The measure of angle 2 is 43 degrees, and that's your final answer for part B. You never ended up needing this 128 degrees here. Sometimes you have information given to you they have to sort through and toss out as not helpful. Now, this practice problem is actually setting you up for 2 corollaries to the inscribed angle theorem. So go back to your postulate paper. You basically just discovered 2 corollaries. Corollary 1, which said if 2 inscribed angles intercept the same arc, if they've cut off arc A and B here, then the 2 inscribed angles are congruent. So you have a shortcut. If you know what this one is, you could assume that angle ADB matches it because they're both half of the same measure here. Then we have corollary 2, which you also just discovered. Corollary 2 says that an angle inscribed in a semicircle is a right angle. This is actually basically using the idea that if this angle is cutting off a whole semicircle of 180 degrees, then it means that it's half of 180, 90 degrees. So anytime you see an angle that's ending on a diameter, it's contained in a semicircle, then you know that's 90. Pause here and try number 4 on your own. So a useful tip for number 4 is to keep that idea of highlighting one angle at a time. For example, if you highlight this angle here, you could figure out it's 100 degrees because it's cutting off a 200 degree arc. It's intercepting a 200 degree arc. Once you know that, you could use the 180 rule from the triangle angle sum theorem and say if you add up the pieces, A must be 40 degrees. Now that's not the only way to solve. Other people figure out A by first figuring out this arc here, but this is one of multiple ways. Either way, you should get 40 degrees. For part B, if you want to solve for angle B first, highlight the sides of that angle and see how it's intercepting the 140 degree arc. So that would be half of that. B would be 70. To solve for A, it's probably going to be helpful to use the triangle angle sum theorem here to figure out the missing angle that's intercepting arc A. So if you use the fact that anything in a triangle adds up to 180 degrees, that's 30 degrees. Double it, and you get that A is 60 degrees. Now go back to your postulate paper. Corollary 3 tells you what to do when you have a whole quadrilateral inscribed in your circle. When you have a 4-sided shape inscribed in your circle, that means that all 4 corners are going to brush the edges of the circle. Now, anytime you have a quadrilateral inscribed in a circle, the opposite angles in the quadrilateral will be supplementary. So here we could say that these 2 angles would add up to 180 degrees. We could also say the same thing about angles A and C. They'd also add up to 180 degrees. So you could use that to solve problems like this one. Pause here and try number 5 on your own. You should get x equals 100 and y equals 109 when you pair up opposite angles and say they add up to 180 degrees. Now, you can do the same thing for question 5b. I just want to point out that you probably want to start by pairing up angles B and D before A and C, because A and C would pair up angles that contain both x and y, 2 different variables. So I would start with the angle B and D pair first. Once you know what x is, it's a lot easier to solve for y, because you could plug x in and solve for y that way. We have one last theorem for today, so go back to your postulate paper. Find theorem 1212. So here we have in this diagram an angle that's formed by a chord cutting through the circle and a tangent brushing by the edge of the circle. And see how the vertex of your angle is at the point of tangency, right where the tangent line hits the circle. Now that angle between your tangent and your chord is cutting off an arc. Here it's a 64-degree arc. The rule described here says that the angle between your chord and your tangent will always be half the number of degrees of the arc cut off in that same space. So half of 64 is 32 degrees. Go ahead and try number 6 using that rule. Pause until you're done. Go ahead and check your answers. So the angle B here should be half of 120, so you get x equals 60. For question 6b, you know the angle first, so you could double it to get the measure of the arc it's cutting off, 194 degrees. Pause here and try number 7 on your own. For number 7, I would recommend first solving for A. A would be half the measure of the arc it's cutting off, so 56 degrees. It's half of 112. There's a couple different ways to solve for angle B. One way is to use the 180 rule for linear pairs. You could just do 180 minus the 56 you figured out for A, and you get 124 degrees for B. An alternate method would be to figure out this arc that B is cutting off and then half that. It should get you the same answer. For part B, let's say you decided to solve for A first. If you look at the angle that arc A is cut off from the rest of the circle by, it's 77. You could double that and say A would be double 77, 154. Calculating what angle B is takes a bit more work. You're actually going to use the triangle angle sum theorem to do that, meaning you need to know what this missing corner of the triangle is first. You could say, oh, that's 27 because it has to be half of 54. Then you can say, well, using the triangle angle sum theorem, the missing corner is 76 degrees, and angle B is the vertical angle to that, so it's also 76 degrees. Pause here and try number 8 on your own. So for number 8, if the central angle here is 44, then the arc here is going to match it. The inscribed angle on the opposite side of the circle, angle A, would be half of that, 22 degrees. And visually it makes sense. This looks like it's about half the width of the central angle here. Now that you know A, it becomes a little bit easier to solve for C. You can add up the two arcs around the outside of the circle that you know, and say, well, if I subtract that from 360, I get the measure of arc C, since the whole circle has to add up to 360. Once you know C, it's easier to solve for angle B because B is half of C. Half 156, you get 78 degrees for B. You should, for 8 part B, get 38 degrees for A. It's half of 76. For C, there's a couple different ways to solve, but see how this line cuts through the center of the circle? It's a diameter, so it's cutting off 180 degrees. You could do 180 minus 76, and that's one way to solve for C. Once you know C, you could half it to get angle B. Half of 104 is 52, because angle B is cutting off arc C from the rest of the circle. Now that you know what A and B are, you could use the triangle angle sum theorem and solve for D that way, or a little bit faster, you could notice that angle D, when you highlight it, is cutting off half a circle. It's cutting off 180 degrees. And you have that theorem that says, oh, that means it's 90 degrees. And that's it for today. Great job, everybody. Don't forget to turn in a picture of your notes on Schoology.